Hi. In this video we're going to continue learning about trigonometric ratios. Well, more specifically, one particular trigonometric ratio. So prior to this, in other videos we've talked about what trigonometric ratios are and how, why they work. We saw that it was based on similar triangles for right triangles, and so we're going to move forward with that, and we're going to look at one particular. We've looked at sine, cosine, and tangent, what they are, and again why they work. So we're going to dig a little deeper in this video. And so the question here says, how can you find the length of a leg? So we remember the legs are the two sides that form the right angle. How can you find the length of a leg of a right triangle? All right, so we're talking about right triangles when you only know the length of the other leg and one acute angle. Okay, so you see that illustrated here. We have a right triangle, we have an acute angle, and we have the length of one leg, and the question is, how can we find the other leg length? Okay, so remember also, if we have a right triangle and the other two angles have to be acute, or you'd have more than 180 degrees. So just keep that in mind. All right, so let's talk about that. The short answer is you can use, in this situation, one leg length, looking for the other leg length. You have an acute angle measurement. Can't use the Pythagorean theorem because we only have one side length, but we can use, there's enough information here to use the tangent ratio. And again, that's been introduced slightly, but let's look at that in greater detail. So, the ratio of the lengths of the legs in a right triangle is constant for a given angle measure. Okay, so that's what we looked at in the previous videos. Given a right triangle and then one acute angle, you have multiple similar triangles. So that means the ratios of those corresponding sides are going to be equal in length, and that's where these ratios come from. Okay, so the ratio of the lengths of the legs, in this case, in a right triangle is constant for a given angle measure. The ratio is called the tangent of the angle. So the ratio of the side lengths of or the leg lengths of a right triangle is called the tangent ratio. All right, so how does that work? So let's just take a random triangle, like we'll call it triangle ABC. Let triangle ABC be a right triangle with acute angle A, all right, and then also B, but just referring to A right now. The tangent of angle A, or the ratio of angle A, written as tan A, is defined as follows. Okay, so the tangent, or the tangent ratio for angle A, would be the length of the leg opposite of angle A. So here's angle A, so this is the leg opposite of angle A, over the length of the adjacent leg to angle A. So remember, adjacent sides share a common vertex. Okay, so if we're talking about angle A and the side adjacent, it's going to have that side's going to share the vertex with the angle that you're referring to. Okay, so in short, the tangent ratio of an angle is the length of the opposite leg over the length of the adjacent leg. Okay, so if we were referring to angle B, okay, let me write this down. So if we were referring to angle B, what's the tangent ratio for B, for the angle B? That would be the opposite leg. So from opposite of angle B is the blue. Okay, we'll call that AC, the length of AC. And the leg adjacent to angle B, okay, is the leg that shares the vertex with angle B, or is the one side of angle B, and it has to be the leg. That would be BC. Okay, so the tangent ratio for angle B is AC over BC. The tangent ratio for angle A is BC over AC. All right, so let's get that down in our note-taking guide. Notice here they're pointing out some abbreviations. Tangent is abbreviated TAN, so eventually you're going to be using your calculator to help you with trigonometric ratios. And on your calculator it'll say TAN. They abbreviate opposite. The book's going to abbreviate opposite with OPP, and adjacent with ADJ. Alright, so same thing written here as here. So here's angle A. The tangent of angle A would be what? CB, or BC, over what? AB. Opposite leg length over adjacent leg length. So here, our letters are a little bit different here. So if we're referring to angle C, that would be the tangent, the tangent of angle C. Go ahead and write it down, because students do get confused with this. So the tangent of angle C would be opposite leg length, which we could represent as AB, or X for the length. It could be an X. AB over adjacent leg, BC. Okay. So what I want to do now, what we need to do now is just look at, determine the ratio, the value of the tangent ratio. And then we'll see how that can be used to find angle measurements. Well, first we'll look at using it to find side lengths. Alright, notice this: unless told otherwise, round values of trigonometric ratios to 10,000ths, okay, place, and round lengths to the tenths place. Alright, so let me get my highlighter here. Trigonometric ratios to the 10,000ths, okay, and lengths to the tenths place. Alright, so in example 1, we're asked, what is the tangent ratio for angle S? So here's S. So what we do is we look for the leg length of the opposite leg length. Okay, that would be RT, or 60, and the adjacent leg length, which would be ST, 25. And then notice 60 over 25 can be reduced to 12 over 5, and 12 divided by 5 is 2.4. So we don't have to round to the 10,000ths place in this instance, because the value ends at the 10th place. So the tangent ratio in this case for angle S its value is 2.4. What about the tangent ratio for angle A? So here's angle R, opposite over adjacent. Okay, leg lengths. So the leg length of ST over the leg length of RT. So here's we're coming from angle R. Here's ST, opposite leg, adjacent leg, because it shares the vertex with the angle that we're referring to. So what is ST? That's 25, RT 60. That reduces down to 5 over 12. Or if we divide top by bottom, we get approximately 0.4167. Tenths place, hundredths place, thousandths place, 10,000ths place. All right, so those are, determine the ratios and their values, and now we still need to learn to, use that to find what we're after is finding unknown lengths and unknown angle measurements. How can you find the length of a leg of a right triangle when you only know the length of the other leg and one acute angle? So that's what we're working towards, and we'll see that we can find unknown angles and lengths eventually. So take note. How did I get there? Let's see here. Alright. Okay, now take a look at this. Well, first of all, notice, whoops, I didn't even, okay, let's see here. Alright, so what are the values for our trigonometric ratios? 2.4 and 0.4167. Okay, so going back to what we saw in the previous videos about similar triangles, so this is the ratio, and so that ratio is going to be true for any size triangle that has the angle measurements that created this triangle. Okay, so in our book there's a table of trigonometric ratios, page 965. All right, and I can use that. For example, the first trigonometric ratio we got had a value of around 2.4. Okay, and so all triangles that have right triangles that have a tangent ratio of 2.4, in this case 2.4751, have an angle measurement of 68 degrees. Okay, again, going back to the previous videos of similar triangles. So angle S is approximately 68 degrees. All right, and angle R was, it had a tangent ratio value of approximately 4.040. And so if I cross-reference that over to the angle column, I see that angle R is approximately 22 degrees. Okay, if you look there in your note-taking guide. So again, this is based on similar triangles, and so you take, just all those values have been recorded. So we take a right angle that has a 1 degree angle, and it's got a sine ratio of 0.0175, a cosine ratio, tangent ratio, and so forth. It doesn't matter if that right triangle has leg lengths of 3 miles and 7 miles or whatever, or 3 inches and 7 inches or whatever. It's going to have these ratios, and so we can cross-reference that back and forth. If we know the angle, we can get the ratios. If we know the ratios, we can get the angle measurements. So that's how we're going to be using trig to find unknown values. All right. So let's do example 2, and then we'll stop and come back on another video. So example 2, find the value of x. Use the tangent of an acute angle to find a length. Okay, so so looking here, we've got a right triangle, we've got an acute angle, and so from this 31 degree angle, we see that we have the leg lengths. We have the opposite leg length, and we have the we can represent the unknown leg length as x. Okay, so we have enough information here to find x. Okay, because since we're dealing with right triangle, this ratio of x to 17 is going to equal the tangent ratio for a 31 degree triangle. Okay, so when we say the tangent of, notice it says here the tangent of 31 degrees is equal to opposite over adjacent. So the tangent of 31 is equal to 17 over x, opposite over adjacent. Remember, this is a value. It's like, if we go back to our table, 31 degrees is, I don't have that on there. Okay, let's say this was 25 degrees. Tangent was 0.4663. That's still a ratio. It's not like 5 over 8 or anything, but it's 7 over 9. It's something. We could take the time to figure it out. But what I'm trying to point out is this is some value. So what I'm looking at here really is a proportion. Okay, but we're just not showing that value. We have it recorded, or your calculator knows it. So now we need to solve for x. Okay, how do I solve for x? Well, I need to get x by itself. Okay, this is 1 over x. I don't want 1 over x. I want x, or x over 1. Let me get my pen here. So what I'm going to do is I'm going to multiply this side by x. Okay, so those x's will cancel out, and what I do to one side I have to do to the other. Okay, put a little multiplication symbol there. And so now I have x times the tangent of 31 is equal to 17. Okay, but x is not by itself. So the last thing I need to do is I need to divide both sides by the tangent of 31. Okay, so again, remember, we're seeing words in an angle measurement, but this is actually, a value. Okay, and your calculator knows what it is, and so this is where scientific calculators come in handy. There's a value for the 17 divided by the tangent of 31. All right. Again, tangent of 31 is approximately 0.6009. So when you divide 17 divided by 0.6009, you get 28.3. Okay. Now what you should do, I'm not here to point, to work with you on your calculator, but you should figure out how you can do this on the calculator, how to plug this in. If you have a scientific calculator, you can do 17 divided by tan, push the tan key, and then 31. Okay, and experiment with that and make sure you can get 28.3. Some calculators, the input's a little bit different than others. All right, so that was a little hurried. Hopefully that makes sense. Okay, so from the 31-degree angle, opposite over adjacent, that's the tangent ratio, so we can say the tangent of 31 is equal to 17 over x. Tangent 31 is a value. It's just like kind of like solving a proportion, and then since we don't have it in proportion form, we're using some algebra to get x by itself. So we're multiplying both sides by x and then dividing by the tangent ratio. All right, so we'll come back to that in another video.